Welcome to Secure and Strong Wi-Fi, Industrial Grade Wi-Fi and Ethernet Bridging webinar with Microchip. In today's webinar, you're going to be introduced to the WFI32 Wi-Fi MCU Module with turnkey bridging firmware that delivers rugged, reliable, and secure Wi-Fi bridging. So our speaker today is Alex Lee. Alex is a product manager at Microchip, managing Wi-Fi products, including wireless module, wireless IC, and Wi-Fi software. He has rich experience of managing software and hardware solutions in the IoT and wireless markets. So what to expect for today, first part of today's webinar will be a presentation, and then we'll have some time at the end of the webinar for a live Q&A. So if you do have questions during the presentation, there is a little Q&A button at the bottom of your screen. Please open that up, type your questions in there, and Alex will answer as many of those questions as possible before the end of the webinar. So thanks again for joining, and let's get started.
Hello, everyone. I'm Alex Lee, the product marketer in Microchip Technology, taking care of Wi-Fi products. And nice to meet you. In today's seminar, I will give you an introduction about the Ethernet to Wi-Fi bridging solution designed with Microchip's Wi-Fi module. In the beginning of my presentation, let me give you an introduction of Microchip's latest Wi-Fi MCU module, WFI32. It would be the core component in our bridging solution today. From the block diagram here, you can see that WFI32 combines the functionalities of MCU, Wi-Fi, and security. WFI32 actually is a high performance and low power 32-bit MCU. It has 1 MB flash and 256 kilobytes RAM. It supports rich communication interfaces such as Ethernet, CAN or CAN-FD, USB, and other general series communications like UART, SPI, or I2C. And all of these interfaces make WFI32 a powerful platform to build an interface bridging application. You can pick an interface and bridging it to another one based on the need in your applications. And now you may ask, what is the bridging solution and why do I need it? The bridging solution is by definition to create a single aggregate network from multiple communication networks. For example, if you look at the picture on the bottom, the Ethernet Wi-Fi bridging is to receive the incoming data from Ethernet network and send it out through the Wi-Fi network, and vice versa. Then, what is the benefit of Wi-Fi bridging? Why do I need a Wi-Fi bridging? In general, the Wi-Fi bridging solution is the fastest and the easiest way to enable Wi-Fi connection on existing host machine. Because in the Wi-Fi bridging solution, we utilize the existing communication interface on the host machine, which is Ethernet. So, any host machine with Ethernet function can talk to the bridging device. And the host doesn't need any software change to drive the bridging device. Wi-Fi software and drivers are also not needed on the host. In the later slides, I will explain the detailed benefits of bridging device. Now, let me share some use cases of bridging, which we learned from our customers. From this block diagram, you can see the red box in the middle is the Ethernet Wi-Fi bridging device, designed with WFI32 module. It is connected to a host machine on the left through the RJ45 and Ethernet PHY. The bridging device grabs the Ethernet package from the host machine and forwards it to the Wi-Fi device on the right. Up to 8 Wi-Fi stations like the laptop, mobile phone, and access point like your home Wi-Fi routers, vice versa. Since the bridging device talks to the host machine through the Ethernet, Therefore, we don't need to modify the host machine software to adapt a Wi-Fi connection. And with standard RJ45 cable, the bridging device can be connected to any Ethernet product. How do I set up the Wi-Fi password and SSID on the bridging device? You can set up the Wi-Fi password by connecting your mobile phone or laptop to the WFI32 as the Wi-Fi station and modify the Wi-Fi configuration through a web page inside WFI32. So, from the overall block diagram, you can find that we can enable a Wi-Fi connection without modifying anything on the host machine. So, what should I use this kind of bridging device for? One of the target applications is machine maintenance. The engineers plug the bridging device to the host machine to do the device diagnostic, investigating the issues, and send back to the laptop. The contribution of bridging device here is cable replacement. Through the bridging device, engineers can also upgrade the firmware of host machine from laptop or cloud. Another application is that some companies' products are Ethernet-based as default, but they also design this bridging device to provide their end customers the option to connect to the Internet through Wi-Fi, in case the Internet is not available in certain application environments. Now you may ask, hey Alex, I know Microchip also sells some embedded Wi-Fi controller modules, like AT-Wink 1500. This module is also used to enable a Wi-Fi connection on the host. What is the difference between an embedded Wi-Fi module and a bridging device? Which one I should pick? This slide is a comparison between the embedded Wi-Fi module and the bridging solution. Let me use the example of Wink 1500. From the block diagram on the left, you can see the Wink 1500 is connected to the host through SPI. And at the host side, you need driver to control the Wink 1500, and you need to develop the application software to implement the driver. And the host MCU you pick should support driver of Wink 1500. Like most of the Microchip MCUs and the ones from other vendors, into which Microchip application team has ported the Wink 1500 driver. Different from the Wink 1500, WFI32 bridging device is connected to host with existing communication protocol the host is using, which is Ethernet. So, any host device or switch with Ethernet functions can support bridging device, and no software related to the Wi-Fi is needed on the host. In summary, if you have an existing product design with ready-to-use Ethernet function, and you want to quickly add a Wi-Fi connection and enter the market, you should pick bridging solution with zero modification on the host and ready-to-use bridging software on WFI32. This is the fastest way to enter the market. But as you know, the Wink 1500 is cheaper than the WFI32 module. So, if you want to develop a cost-effective Wi-Fi product, then you should pick Wink 1500. But you have to spend extra effort to design the Wi-Fi related software on the host. And the host MCU must support Wink 1500 driver. For example, the MCU you are using is from like Renesas. You may not be able to drive the Wing 1500, or you need extra time to port driver to your Renaissance MCU. Maybe your next question is, compared to the other Wi-Fi modules in the market, why I should pick Microchip's WFI32 to design bridging device? First reason is WFI32 is the unique Wi-Fi MCU in the market with all of the communication protocols like Ethernet, CAN, CAN-FD, USB, and Wi-Fi. So it can be designed as various types of communication bridging solution. Now we have Ethernet to Wi-Fi bridging, and in the future, I can introduce you the CAN to Wi-Fi bridging. And our team is also developing the other bridging applications like USB to Wi-Fi bridging or the UART to Wi-Fi bridging. Secondly, Microchip can provide high-efficient turnkey bridging software and application example. What you need to do is to download the binary file from our GitHub and program it into WFI32. You don't need extra software design work. And why I call it high efficient, I will explain it in the later slide. Third reason, so Microchip provides total system solution. We not only provide Wi-Fi MCU module, but also other key components used in the bridging device, like the Ethernet PHY. Microchip has competitive Ethernet PHY product, and we can provide you the systematic support on the complete circuit design. Usually, such kind of bridging solution is used in industrial applications. And we know our customers have high requirement on the industrial products. So to help you design industrial level RF products, Microchip provides robust and secure Wi-Fi module and free wireless design checking services. Our application team is ready to support you on your RF product design. Now, let me introduce our Ethernet Wi-Fi bridging software. So, to do the bridging, a general idea in our mind is that we receive a mailbox from Ethernet, we open the box and get the raw data and put it into another box and transmit through Wi-Fi. However, the Microchip software expert designed bridging software in a different way. Every time WFI32 receive a data from Ethernet, data frame from Ethernet, it just forward it to the Wi-Fi network. Yes, maybe you can see the difference, the key difference. The key difference is that our bridging software doesn't open the mailbox during the whole bridging procedure. We simply forward the whole data package from the one side to the other side. This way, we can largely improve the transmission efficiency and reduce the software size. This slide gives you a complete overview of software features of WFI32. So what software functions we provide and what tools we provide. And all of these resources can be found in the Microchip Harmony. So looking at this block diagram, so to help you quickly and easily develop the application, Microchip provides the codeless Wi-Fi development framework. With this framework, you can get the Wi-Fi function run without touching the source code. And we also provide the rich system level example applications covering all the Wi-Fi and MCU functions. And the drivers for the MCU peripherals and external Microchip add-on devices are also provided. So in your bridging application, you don't need to worry about the drivers of the Ethernet PHY. Secondly, regarding the security, to help you build a secure Wi-Fi connection, we provide various types of the secure software, and actually I can explain later in the next slide. Then let me talk about the functionality. Okay. So besides the application examples to evaluate the basic product functions, like the MCU peripherals and Wi-Fi functions, we actually focus on adding values to your application, provide you the turnkey software to solve your problem in your application. For example, we provide various types of the bridging software. Today, we're talking about the Ethernet Wi-Fi bridging, and actually, we also have the CAN or CAN-FD to Wi-Fi bridging. And another example is we provide rich the application examples to help you connect to the IoT cloud servers like the AWS and Azure. Next, we talk about the robustness and reliability. Okay. Our software also plays an important role to build a robust Wi-Fi product. For example, we provide WFI certification and interoperability testing on our existing Wi-Fi modules. We also provide convenient GUI tools to fine-tune your RF and debug your system even down to the register level. We also provide software tools to test the functional safety of your product. In previous slides, I mentioned a little bit about the security, and in this slide, I will introduce more about it. Besides the turnkey bridging software, WFI32 also help you to build a secure network connection. For local Wi-Fi network, WFI32 supports WPA3 secure standard, the latest Wi-Fi security standard, which is compulsory to WFA certified product. For example, if you want your product is certified under the Wi-Fi Alliance and with your Wi-Fi logo, your product needs to support WPA3. And later this year, we will also release enterprise Wi-Fi security to let the end product join an industrial Wi-Fi network, like school, hotel, company, or factories. If you want to bridge your device directly to Internet cloud in a secure way, Microchip provides TLS software library, Wolf SSL, and the Trust and Go WFI32 module. What is Trust and Go module? It is a special module variant under WFI32 family. With Trust and Go module contains the hardware secure element, which has keys and certifications used to join a secure IoT cloud. And the hardware secure element provides the best-in-class protection on the keys and certifications. The certification has been pre-provisioned to the world top 2 cloud servers, AWS and Azure, so that the users of these 2 cloud platforms can easily register them to their cloud accounts. Next, let me explain why I call WFI32 a robust Wi-Fi module. The first reason is we have done intensive testing about interoperability on WFI32 to make sure it can communicate properly with other Wi-Fi products in the market. Secondly, WFI32 has robust and stable RF performance, work properly in various types of application environment. Third reason, WFI32 has proven to work network stack software with version control and regression testing, such as the TCP/IP stack and the wireless LAN net software. which are the key components in the bridging application. What's the meaning of version control? That means our software is not one-time given. We keep updating the software versions by adding new features following the industrial trend. So in summary, with WFI32, you can achieve high product performance to meet industrial requirements, and you can minimize the expense on the issue diagnostic and avoid product returns. Next, let me talk about the interoperability. To design a robust bridging product, you must make sure the Wi-Fi software is able to communicate to the access point in the market. If your Wi-Fi product cannot talk to certain widely used Wi-Fi routers, that will largely damage the product branding reputation and bring extra cost to debug and test. Every time Microchip releases a Wi-Fi module product, we have tested it with 65 popular access point routers in the market. And 65 may not be a big number, but they cover 35 Wi-Fi chipset product families from 10 big Wi-Fi IC vendors. And these 35 Wi-Fi chipset families are used by about 2,200 AP products in the market. About 82% of total access points introduced since 2014. So next, let me talk about the robust RF performance of WFI32. WFI32 has stable RF power over environmental temperature change. That is to say, WFI32 can maintain the good transmission distance and throughput even under extreme temperature. WFI32 also has excellent adjacent channel rejection. What is the meaning of adjacent channel rejection? That means WFI32 can be a reliable RF transceiver in the presence of a high-level interference noise in the adjacent channels. So in summary, even in an environment with high noise and extreme temperature, WFI32 can still maintain stable and robust Wi-Fi connection. Next, let me talk about the functional safety, one of the important portions in the robust product. As you know, the robustness, reliability, and safety of end products are becoming even more important. In some application segments, these requirements are formalized and mandatory, while in others, this is implemented to differentiate the product and take the step from a good product to an excellent product. There are several global functional safety standards, such as IEC 60730 and IEC 61508. Currently, WFI32 supports IEC 60730, the standard used in appliances, such as washing machine, oven, microwaves. And we are working on to support IEC 61508, the industrial focus standard, for example, industrial robots and machines. So, why do we need IEC 60730? Because it defines the safety standards at the system level, addressing safety of electronic controls in appliances. It contains effective test and diagnostic methods, ensuring the manufacturers have designed their products to operate safely. Currently, it is mandatory for appliances sold in Europe, and its widespread adoption is highly likely. So what has Microchip done on this? So Microchip provides testing libraries to meet IEC 60730 requirements, such as CPU register testing, program counter testing, and EEPROM testing and clock testing. This is the effective tools for you to certify your product as IEC 60730 qualified product. We have dedicated GitHub site in Microchip Harmony with testing source code example and user guide. After the introduction of WFI32 bridging, our software features our robust and reliable art performance. I believe some of you cannot wait to try the solution. So in this slide, I list all the supporting materials you need to build your bridging application. First, we provide application example Ethernet to Wi-Fi bridging in the GitHub. The GitHub site contains the ready-to-use software source code user guide, and customers can just build the software and program the binary into WFI32 module. And in the application example, we provide the default settings about the Wi-Fi and the Ethernet. And if you agree with all of these settings, you don't need to modify the source code and just use the binary directly. If the customers want to understand the detailed knowledge about our bridging software, we have the knowledge-based article for them to learn. And for example, the customers want to understand how do I configure the Ethernet and the Wi-Fi in the same device, how to change the DHCP setting, or how to change the SSID Wi-Fi setting, security setting. This article can help you. And we also have the video to be used together with the knowledge-based articles. The next I will talk about something about the hardware. To do a bridging demo or development, customers should buy the WFI32 QRSD board and Ethernet PHY daughter boards. Then they can use them together with their home routers and laptops or mobile phones. If you have customers interested in this bridging solution and you need special support, feel free to reach me. I list my email address here. We provide easy to set up demo for customers to evaluate the bridging function. The hardware you need for this demo include WFI32 QRSD board, Ethernet PHY daughter board, your mobile phone, home router, and your laptop. From this block diagram, you can find the WFI32 QRSD board is connected to the laptop through a home router. And on the other side, you can use your mobile phone connect to the QRSD board with Wi-Fi. The WFI32 here works as a soft AP. The function of this demo is quite simple. It just measures the throughput with the iPerf apps on mobile phone. If your application is not as simple as the throughput measurement, like for example, your application is video streaming or large file transmission or the remote firmware upgrade, then you can use any kind of TCP/IP application, your own application on either mobile phone or laptop side. And you don't need to change the firmware inside WFI32. Some customers have some special requirement like the Ethernet and the Wi-Fi. For example, they want to set up the Wi-Fi password, then the Ethernet. For the Ethernet, they want to choose the DHCP or not. So to help you easily set up and configure the Wi-Fi and Ethernet network before building the bridging software, we have instruction video to explain the procedures step by step. And all the source code and user guide about this demo can be found in the GitHub site I listed in last slide. And you can also enter the website by clicking the link here. Our Microchip WSG system application team is ready to support you on any kind of questions. Now let me introduce the WFI32 board, the full functional evaluation board of WFI32 module. So looking at the picture of the board, you can find on the right, that is the WFI32 Trust and Go module. Since it is the Trust and Go module, that means the whole development board has been preparation to the IoT cloud server, AWS and Azure. So we also have the out-of-box demo about cloud connection about it if you need. And looking at the components on the board. Yeah, of course you need the Ethernet connector to connect Ethernet 5 data board to realize your bridging software function. But beside the Ethernet, you can also find they have several standard Microchip standard headers. For example, the export headers to connect to some kind of the daughter cards from Microchip. And there's the header called the microelectronica clickboards, and it can connect various type of the clickboard from microelectronica. And we also have provide the GPL headers. That means if you want to add some extra functions on top of your Ethernet Wi-Fi bridging device, like the push button, touch button, sensor, or the other kind of functions, yeah, the board is ready to serve you. And you can find a rich kind of the document user guide examples to use the board. In almost the end of my presentation, I believe many of you have been very interested in the bridging application, and you really want to buy the modules, the WFI32 modules. And here I give you a list of all the module variants and the support certifications. So in general, Microchip provide 4 types of the module variants. And if you look at the part number end with the PCI and UCI, PC-I and UC-I, these modules are trust and go modules. That means these modules have been preparation to IoT cloud servers, AWS and Azure. The other 2 modules are the normal modules, which doesn't include the trust and go feature. Yeah, these modules end with the PE-I and UE-I. Another difference is we provide modules with PCB antenna and modules with UWL antenna connector. So if you want to design a very compact bridging device, and you don't want to use external antenna, so then you can choose the PCB antenna module. And if you want to have a better RF performance and use external antenna, then you can buy the module with UWL connector. So all the modules have been certified for the FCC, Europe, and Canada certifications. And for the PCB antenna modules, we have certified them for some other countries like the China, Taiwan, Japan, Korea. Yeah. Now this is the end of my presentation, and thank you very much to join the webinar. And next, I'm here to answer the questions you have.
Great. All right. So I think we got a couple questions that came in. And so we'll start with those. And we also got some questions came in through registration earlier, so we'll talk about those too. If you do have questions that you didn't get a chance to ask, go ahead and pop those into the Q&A and we'll make sure to get to those before the end of the webinar. So let's start with the first one. Is the bridge audio video bridge AVB compatible?
Well, you know, in the microchip, we have several type of the Ethernet controllers supporting AVB. But I need to check with our Ethernet expert to see whether the WFI32 can work with them with the Ethernet controller to realize this function. Yeah, so I will get back to you on this question. And yeah, as you know, the WFI32 from the speed, if you look at the speed of the MCU, the speed of the Wi-Fi, and the memory size, we are able to do the audio and video streaming. So I believe from technically, I believe it is doable, but I just need to double confirm.
Okay, great. Another question, could this be used as the basis of a WAP?
Yeah, the bridging device can be used as the station mode and the wireless access point mode.
Great. Another question, how can I use this to make a better design for IoT and automation?
So yeah, I mean we provide you the ready to use application examples, and for with good IoT support, like the IoT cloud, and so from the software side, you can realize a lot of the IoT functions, and from the product performance side, the WFI32 is the quite low power the Wi-Fi MCU. So that means you can design very low power IoT product. And yeah, and we have our robust Wi-Fi performance, the product performance also meet the industrial requirements. So yeah, it can be used in the automotive. Yeah.
Great. Do you have cellular integration for these bridge components?
So what the meaning of the cellular integration? Sorry, yeah.
Michael, can you help clarify what you mean by cellular integration? And we can move on to the next one and then come back to that one. The next one is, how much current and voltage are needed for these modules?
Well, that's really current consumption really depend on the working mode. So let us say if you on the mode is when the Wi-Fi is working, the RF the radio is turned on and MCU is in the full operation. So the power consumption can be about the RF power consumption can be about the 200 milliamp. So that is quite normal in the Wi-Fi operation. And actually, but if you put the device into the deep sleep mode, that means no operations, and the power consumption can be down to below the 1 microamp. So for the detailed power consumption, I would suggest you to check the data sheet of the WFI32. Yeah.
Great. Looks like how many watt is that? Is the follow-up to that same question that you were just answering. Okay,
so yeah, so it is challenging my physical knowledge. You know you can find the current in the data sheet, and you know the power supply we have the 3.3 or 3.6 3.6 volts. So yeah, you can find the watts there, but at current state I don't have the exact answer for that. Yeah, but yeah, if you need to know details, yeah, certainly I can get back to you. about in watts.
So is it about 1 watt is give or take?
1 watts. That is quite high actually. So I don't think we can achieve 1 watt. So that means yeah. So the you can see the 200 milliamp as the highest power consumption, and times 3 volts, 3.3 volts. I don't think that no, the 5 volts, we support the 3.3, maximum is 3.6 volts. So yeah, thanks for the formula. So you can see about the 0.7 watts, something like that.
Gotcha. Yeah. Okay, great. And then we had clarification from Michael on that question before. Do you have cellular integration? And by cellular integration, he means connection with any cell radio chips or module for these bridge components?
As you know, as long as this radio chip has Ethernet, so yeah, as I said in my presentation, so yeah, this module, the bridging device can connect to any host device with Ethernet port. So it can be the RJ45, it can be the RMII so part. So actually, yeah, so the WFI32 doesn't care what is on the another side. Is it the radio, the cellular, cell radio, or any? Yeah, it just care whether this chip has Ethernet or not.
Okay. So is the board long range, or is it long range? Sorry, I don't know if it was the board or.
The long range, yeah. So we follow the stand. I cannot give you exact the range in meters now, because it really depends on the environment of the radio frequency, and yeah. But I can say the Wi-Fi is long range, and yeah, compared to BLE, Bluetooth or the others, but compared to our competitors, we can achieve the largest transmission power. So maximum transmission power. That means the transmission power is the key to achieve a long range. So I have to say that compared to our competitors in the markets, WFI32 it's easier. Yeah, it's easier to achieve a long range. Yeah, compared to others. Yeah.
Great. For the 4 modules you mentioned, what are their throughput?
Well, the throughput, the range of the throughput is from about the 220 Mbps to 30 or to even 40 Mbps. Really depend on you using the TCP/IP, which use the TCP, use UDP. So I have a list of the throughput for the Wi-Fi only. So here, to be clear, we have done some measurement for our Wi-Fi product, just the Wi-Fi speed. So I can provide you the list of these the throughput in different modes. Regarding the throughput of the bridging, currently we are on the process of the testing to give our customers so the standard, the measurement about the bridging throughput. And so I can certainly send whatever we have, all the measurement we have done. And so actually you can also find it in our public the presentation of the WFI32. So I can distribute it through the Ethernet. So yeah.
Great. What is the advantage of the WFI32 compared to other vendors' products?
I think what we are focusing on is the robust wireless and high performance MCU and the good support. So three things. And as I said in my presentation, so we have the stable RF performance, and which is the industrial friendly. And as you know, as the MCU, you know, the microchip MCU is famous. It's popular. So because we have this kind of advantage of the microchip MCU, the customer support, product performance, and the development environment. So so this is the tradition. I have to say the WFI32 inherited the traditional advantage of microchip product, microchip MCU. Yeah.
Awesome. Are your modules, are they shielded from RF?
Yes.
Okay. What other bridging solutions do you have? Any future plans for additional bridging solutions?
We also have the CAN FD to Wi-Fi bridging. So this is quite useful in some onboard diagnostic device used for the automotive. So so the user can just plug this kind of the device onto your car, and with the CAN or CAN FD bus. And on the other side of the laptop, you can monitor all the problems or the kind of operations. So this is also very useful bridging solution. So we also have the ready to use application examples, and you can check that in the WSG, the Microchip WFI32 product page. Yeah.
Will you provide the source code of bridging solution, and where can you find that source code?
You can find the source code in the GitHub site in my presentation, and so you can access the source code of the application examples. And but I think we still have some libraries that is we don't open to the customer, but it's free to use by our customers. Yeah.
Okay. Can you confirm your modules can operate from -40 degrees Celsius to 85 degrees Celsius?
Yes. Yeah.
Great. Can I modify the bridging software, and how do I do that?
That's really depend on the level of the modification you want. So, for example, if I just want to modify some the Ethernet setting like DHCP, fixed IP, or how many, and also the Wi-Fi settings like how many clients I want to connect, and what is the security levels. We provide you the great tools. We call it the Microchip Harmony. So this is the GUI tools for you to fill in the numbers, the settings you like. Actually, you don't need, for this kind of customization, you don't need to access the source code to do that. Okay. However, if you want, for example, I want to add a touch button on my bridging device, or I want to add some LED functions on my the bridging device. This way, you have to access the application examples, and we provide you the source code of the application examples. You can start from there. And if you have any questions, just raise a ticket, and for technical support, we can assess you to we can help you to get your function done. Yeah.
Great. This is a good follow-up to that. What kind of support does Microchip provide for getting started in development?
We provide you all the existing application examples, and our support will what will be any questions you have on these application examples, and any questions you have on the or Wi-Fi software or any software in the Microchip Harmony we provide. And besides the software, we also support you to get your hardware design done. You know the radio frequency related design is quite sensitive, and sometimes you put your wireless module in a wrong location, so the RF performance will be totally different. So one of the great things we provide is we call it the wireless check services. That means you can just raise a ticket, so we can assist you to review your RF design. And no matter we don't care your annual purchasing volume. That means if you just purchased about 50 pieces a year, we are here to serve you. Yeah, and we can help you review your circuit, your design, and provide meaningful suggestions. No.
Great. Do you support Wi-Fi 6?
Currently not, but we are developing in our next generation the Wi-Fi MCU product.
Okay. For mechanical mounting, do your modules, or can they fit on RJ45's footprint?
I have to say our module is a little bit bigger than the top RJ45 socket, a little bit bigger. So, yeah.
Great. And then I guess if so, then do we lose the RJ45 port on our device? Was a follow-up to that question.
Yeah, so that is really depend on the application, the design purpose. So some customers, they just design the very small board PCB with our module with the Ethernet PHY and RJ45, a very small module, a very small PCB, and it can be plugged to some kind of the host machine. But another preferred way is to lose RJ45. That means that we use the RJ45 cable connect between the host machine and the bridging device designed with WFI32. So yeah, so this way we can avoid some kind of interference and make the better RF quality. Yeah.
How do you program the board? Is there do you have some advice on that?
Program the board. Yeah, so actually, I remember I have a slide talking about the development board, and they have the procedures to use it. That means you download the Microchip IDE and download the Microchip Harmony and all the programming tools. Then you can just program the board. Yeah.
Great. And I think there were a couple questions that came in on the chat too about the slides and the recording. So if you missed that part, there will be, we will send out an email later this week with a link to the recording along with those slides. So if there is anything that you missed earlier on, you should be able to grab that in a couple of days. I think we have one more question. If you guys do have some more questions, we still have about 5 minutes, so we can answer a few more. But here's another one. What is the speed of Ethernet? What speed of Ethernet is required for your modules?
Our module doesn't have the requirement of the speed for the host. That means if you so that really depends on your Ethernet speed on the host machine, and we just do the bridging. So yeah.
Can we use 5G, 10G?
That's why I need to check. Yeah, because if the throughput the internet, the host machine is too fast, I need to check the limitations because part. Yeah.
All right, so we are good for the day. Thank you so much, Alex, for joining us and for your presentation. Thank you for all of those who came and watched, and we will see you next time.
Yep. Thank you, everyone.
Bye.